of you. So let's start with the class. So guys, today we are Lana says that you look like you haven't been sleeping how many hours. Yeah, even last week, not last week, so even this week, so a lot of things we were building. So the production bug and all those things, we were trying to sort out all those things with the team. So yeah, barely getting time to take a proper sleep, but that's completely fine. So I think it's not a big issue. Yeah. So let's start with the class, guys. So by default, by the way, guys, I'm going to talk about image processing in today's class. So first of all, I'm going to introduce a library called as OpenCV, which is one of the popular, I would say, library which has been used in terms of doing image processing. And I believe you must be using a lot of filtration feature in your mobile device. Maybe you are uploading something on Instagram, maybe you are uploading something on a YouTube, or maybe you are trying to take a picture and then you try to apply a lot of filters, contrast, brightness, all of those things, right? All of those things. So similar kind of things we are going to see that how we can do it with the help of code, because if you are using some sort of a tool in your mobile or even a default editing tool inside your mobile devices, technically someone has written a code, right? Technically someone has written a code, and just because of that code you are able to perform all of those operations. So similar kind of things we are going to see with all sort of a small application. And then I'm going to show you lane detection. So lane detection plus I'm going to show you basically all those object detection with the help of YOLO. Even I'm going to show you how you can try to take a feed from a live camera. So from my alternate camera, so how I can try to take a feed and how it will be able to detect each and everything in my surrounding, right? So all of these applications we are going to see in my today's class. So let's get started, and let me launch my VS Code so that I can start showing you these applications. So it's a game of library and models that we are going to use. So file, let me create a new folder. So inside this code directory, FSDS computer vision, CV is a folder name, and I'll keep on pinging you the code inside a chat so that you all will be able to, practice each and everything along with me. So here, let me create a new file. So first of all, I'm going to create a IPYNB file, OpenCV demo.IPYNB. So IPYNB file, and here what you have to do is, so you have to install a OpenCV, then only it is going to work. Otherwise, it is not going to work. So maybe what we can do is we can try to create a a fresh new environment for this particular stuff that we are going to do with Python 3.10. So let me create a new environment for all of you. So here I can write conda create -n, and I'm going to give an environment name OpenCV or maybe FSDS CV, and then Python is equal to 3.10, and yeah, install everything. Yes. So this is a new environment, guys, which I'm going to create. I will be using this environment in my today's class. I have just pinged you the code. Yeah. So this environment is ready. I can try to activate this environment. So yeah, this environment is active. Maybe I can show you even in a command cell. So this environment FSDS CV is ready, and yeah, I can try to use it. So here the major library that you have to install is OpenCV Python. So library that you have to install. So like I said, if you'll go to Google and try to search for OpenCV PyPy, so OpenCV PyPy repository, you will be able to find out this command, pip install OpenCV Python. Now what OpenCV can be used for? So OpenCV is one of the most powerful library, or I would say one of the only library you will be able to find out which is going to give you a high level APIs, or you can say a function, so by which you will be able to do all sort of a manipulation with respect to your images, right? So with respect to your images, that is something OpenCV is going to give it to you, and it's very powerful, means literally it's a very powerful one. And maybe I can try to show you some official documentation. So here, if you will come to opencv.org, it's one of the oldest one of the most updated one, and across a world, people are contributing for this OpenCV. So you will be able to see a lot of application that you can try to build with the help of OpenCV itself, right? With the help of OpenCV itself, and all the big companies across a world, so they are contributing in some way, basically, to OpenCV. And it's you can see that it's a 20-year-old library, right? It's a 20-year-old library, and just imagine 20 years back we were not even able to imagine where this entire AI will go. But yeah, and since 20 years, so this library is performing well. That's the reason I said that it's only one library that you need in terms of doing image processing at the end of the day. Yeah, so and a lot of application you will be able to find out on OpenCV. So basically like a facial recognition, a lot of things you will be able to find out. But today I'm going to show you some of the basic operation that you will be able to do with respect to this library. And it's an amazing library that people have actually built. Yeah, it's literally amazing. And anyone who would like to build their career in basically computer vision area, especially in a computer vision area, so obviously you should be aware about OpenCV. And again, one more thing. So you should not be you should not go through basically a code, or you should not remember any of these code or APIs, because yeah, with the help of LLMs, with the help of AI, we can try to write it down. But yeah, you should understand the basic, that what OpenCV can actually do, right? So what OpenCV can actually do, and believe me, it can do almost everything that you can think about. So that is something which I'm going to show you, and obviously you will see that it's going to be a little bit unbelievable for all of us. So let's get started, guys. First of all, we have to install this OpenCV. So pip install OpenCV-Python. Now I'll just go to my environment and pip install OpenCV-Python. I have pinged you the code, guys. Yeah. Okay, so this OpenCV is installed inside my environment. So this OpenCV is already available now. Now what I can do is I can start writing maybe some sort of a code, and then I can start showing you some sort of a modification with respect to my images. Now to do that, I need a image. So maybe I can try to keep one of my image over here. I can come over here and then I can try to rename it SUDH JPG. So I will be using this particular image, and with respect to this particular image, I'm going to show you a different kind of a transformation that possibly we do it in our mobile devices, or whenever we try to take a pictures from a camera, right, by using any of the tools or any of the software. So let's start writing it. So first of all, you have to do the import. So you have to do a import, and then import as a CV2. So you can import OpenCV as a CV2, by the way. And for that, so I have to attach my kernel and FSDS CV. This is the environment which I have created. So just try to do the import. And yeah, if I'm able to import it, it simply means that CV is installed inside my system. Fine, guys, everyone. Yes. So I have not done much so far. I have just created the environment, and I'm just trying to install the OpenCV. I'm trying to import it. My import is successful, and I have just kept one of my images over here, so that with respect to this image, I can show you a multiple different kind of a transformation. So here, first of all, I have to read a image. So OpenCV gives you a read image feature. There is something called as imread function you can try to use, and then you can try to put your image name, and it is going to read the entire images. Now at the end of the day, images are nothing but a NumPy array, and I believe we all are aware about it. I have already shown you, and I have even told you in a beginning itself that whatever images that we are talking about, it's technically in terms of like a system, in terms of your hardware. So it's a NumPy array, especially in a Python. So it's basically a NumPy array, and this is how it is going to treat. So here you must be able to see that it is showing me a 3D image. I have uploaded a colorful images. It will be having 3 layers, R, G, and B. And because of that, right? Because of that, so it is showing me that part. Just a minute, guys. Okay, yeah. So this is something that it is trying to do. So it is able to read my images into a NumPy array, and it's technically a 3D array. Basically, we have a R layer, then G layer, and then we have a B layer. So back to back, back to back, and that's the reason. So it is going to show me a 3D layer. And again, so from index 0, index 1, index 2, you will be able to extract layer by layer, all the information. And if I can extract it, obviously I will be able to do a lot of manipulation, right? I will be able to do a lot of manipulation with respect to this particular images. And I think I have already shown you, but yeah, so even in a manual way, so I will be able to do a manipulation. So here I'm going to store this entire NumPy array inside a IMG, right? Inside IMG. Now, so there is something called as I can try to show you this entire images into a different kind of a color scale. Basically, maybe you must have used your photo with the blur, or maybe with the black and white in your mobile, or even now if you are going to take one photo and if you're going to click on your filter option in your photo in your mobile device, you will be able to see a different kind of a filters. Now those different kind of filters are nothing but adding, subtracting sum of the numbers. As simple as that. Adding and subtracting sum of the numbers, nothing much. For example, so if I have to show you this entire like a array, means the image which I am able to read out in a Python, so I will try to use a very simple function. So imshow. So there is a function called as imshow show, and then here so I can try to call my img variable, and it is going to show you the entire image. What happened? Error 5 bad. imshow. Okay, so what is a nature window name, then mat imshow window name. Okay, show. Yeah, so this is showing. Why it is not showing, not responding? Close the program. Once again, restart kernel, import, and then show. Again crashed. Why? It will show, it is actually showing, but yeah, so because of my system utilization, so I believe it's giving me some sort of a pain in terms of showing you the actual image in a separate window. So CV2 imshow and show me. Okay, let me write something. So cv2 dot wait key, and then cv2, just to handle the situation, destroy all window, destroy all window. Yeah, so as you can see that I'm able to see the original images, right? So it's nothing but the NumPy array which I'm trying to show you, and this was the image which I have taken, and this was the image which I was trying to read out. As simple as that. Yeah, now I'm closing it now. So here is the image read operation, guys, a simple im read, and this is going to read your images, and then I'm just trying to use imshow function, this wait key and destroy all window, just to handle those exceptional situation, because it was not allowing me to read the image properly. So I have just used a wait key, so that it is going to initiate some sort of a sleep operation for my CV library, and then destroy all the window, means close all the window. Okay, now so I'm able to showcase this particular images in this particular manner. Now I'm going to show you same image into a different scale. So let's suppose if I have to show you maybe images in a grayscale. So cv2 dot, I can try to use a function called as cvt color, and here so I can try to pass a color and images. So show me this particular image by using a cv2 color, 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 and there are a lot of like a color code that you will be able to find out. So BRG to gray is something which I am looking for. BRG to, or let me write it down, color and underscore BRG to RGB to grayscale. Let's suppose if I have to showcase, so color and then BRG to GRA Y gray. Okay, and then this is going to convert my image into a grayscale, and maybe I can try to show you this grayscale images. So by using the same thing, cv2.imshow over here, and then GRAY. So just name the window as a gray and show me this gray variable. Let's see. So what happens? Again not responding. Sorry, this is saying it is not having kernel died. CV2 and color COLOR BG, okay, GR to GRAY. So its name is bit complicated. GRAY. Yeah, now I'm able to find out. So BGR2 gray. Now if I'm going to execute it, you will be able to see this is my original image, right? So I'm trying to show you this show, right? So is the window name which I had given, and then here you must be able to see a same image. I'm able to convert it into a grayscale. Yeah, a grayscale. And I believe in our mobile devices, so we have a similar kind of a filter operation, so where we can try to convert our images into a different scale, right? So this is how this things actually happens. Just with the help of code, I am able to do it, and in your mobile, just with the help of like a click, you will be able to do it. Now, so likewise, there are so many other color coding that you will be able to find out. Almost all the color coding that you are able to find out inside your mobile. So each and everything you will be able to find out here. So let me show you a couple of more. So here I'm going to show you HSV. So here cv2 dot color color underscore bgr to hsv. Yeah, this one. So bgr to hsv, and here hsv, if I'm going to call hsv, and if I'm going to show that cv2 dot imshow, and this is window name is hsv, and here so I'm showing hsv variable data, by the way. Now if I'm going to execute it, so see, this is basically a hsv type of a data which I'm able to find out. So like I said, guys, likewise, there are so many different kind of color encoding which you all will be able to find out, and whatever you want, you can do it with respect to this one. So HSV is nothing but it's called as hue, saturation and value. This is one of the again color coding that we try to use. So hue, saturation and like a value. Maybe you must have seen a saturation icon. You must have seen a hue icon inside your mobile, like a image editor basically, or maybe even inside your desktop image editor. You must have seen this kind of a icon. So where we try to drag and drop and we try to change the values. Now this is something that we are able to do it with respect to a library, and we are trying to alter just a pixels, a numpy that we had, the numpy array that we had. So we are just trying to play around with those numpys. That's it, right? And even in a manual way, by doing some sort of addition, by doing some sort of a subtraction, I will be able to perform the exact same thing. Is it making sense to all of us, guys? Yeah. Yes, everyone. Okay, so now let me print the size of the images. So that is again very simple, as we have a numpy array. So I can just try to call numpy shape, and it is going to give me img, right? Not imp. So image dot shape, and this is the shape of my image, and it clearly says that it is having a 3D in nature. So height, width, and depth, as you can see. So number of arrays or number of element into a height, and then width, and then depth, or number of layers in across all of these three channels. So we are able to find out. So this is the image shape that we have. Now let's suppose if I have to play around with the image shape, if I have to resize the images, right? Same images, if I have to resize, maybe I have to showcase these images into a low resolution, and generally we try to do that, right? So we try to showcase some of the images into a high resolution, some of the images we try to showcase into a low resolution. I can do that. So how I will be able to do it? So just I have to call a numpy resize, and similar kind of a function you will be able to find out inside a CV2 as well. So resize, size, size function, it is doing nothing. So basically like trying to take the numpy array and then trying to realign it. So img I can try to call, and then size I can try to define. So maybe 300 cross 300 in this ratio. If I have to showcase my images, I can show that. So resize, resize, and maybe I can try to call this image show, im show, and here, so I can try to just use this numpy array to convert into a pixels. So size, resize. So as you can see, now my image became small, right? So this is basically a small images. Previously the size was very, very big, but now the size of the same images is very, very small. And yeah, so this is how you will be able to do a resize operation, just like a numpy. Basically, let's suppose if I have to perform some sort of a rotation operation, right? So if I have to perform some sort of a rotation operation, so how I will be able to rotate the images, let me show you that part as well. Like I have to rotate maybe a 90 degree, maybe a 30 degree, maybe 31 degree, maybe 180 degree. All of these operations are possible. The way we try to like rotate it with the help of like some of the icons or some of the buttons or tabs inside our machines, Windows machine, or maybe into a mobile devices. So here, if I have to perform a rotation operation, right? So first of all, let me extract height and width. So height and width, and here I'm going to show that image img dot shape, and try to consider a shape starting from all till 2. So this is going to give me the height, and this is going to give me the width, as you can see. Yeah, so height is here and width is here. So from image shape, right? Image shape has given you this one. Image shape has given you this one. So out of this, I'm just trying to extract these two elements. One is a height, one is a width. I'm just trying to extract that much. Nothing much I'm trying to do over here. So once I'm able to extract this height and width, I can try to call a CV2 library, and then there is something called as get rotation matrix 2D. So this is going to help me out in terms of rotating my images. So here I can say that width, and then try to take out this one, then height, try to take out this one, and wrap it up, and then rotate it by using this. So here, so we are trying to give all the points, by the way. that how much we are trying to like rotate, and let me show you the result so that you will be able to understand. So rotate is equals to this, and I'll be using same IM show, this time just with a rotate. So rotate I'm able to get, and then I have to show you the final image. So CV2 dot wrap fin. Again guys, so no need to remember all of this function. Like I said, there are more than 10,000 function which is available, by the way. So rotate variable, just call it and then give a width and height. Width and height. Okay, so this is going to give me the rotated image R. I'm just going to use it here. Name the window size TAT rotate, and as you can see, so I'm able to perform this rotation operation, right? So again, the way I am looking for this rotation, so I can do it in the easiest possible way, depends upon me. So here basically we have defined a couple of variable in this particular place. So I have defined basically this particular parameter. Now what this particular parameter is doing, so here it is going to decide a center of rotation. So I'm saying that center of rotation is my width and height of the image, right? So that is the center of the rotation. The 45 degree which I have defined over here is basically a angle. So rotate it from a center, right? Flip it from the center, rotate it from the center by 45 degree. And the one that I'm trying to define, so I'm just trying to say that keep a size of the images same. So don't try to change a size of the images at all. This is what I'm trying to say over here. I can try to like play with it, and maybe I can try to change this particular angle. So here I can say rotate by 180 degree, and don't keep a original size. Maybe just try to take a 0.8 of it, and now see 180 degree, and even image size is been reduced, right? Image size is been reduced. Now it's a 80%, just a 80% it has taken. So I have just like changed that particular part as well. So here you can try to control a lot of things. Like I said, here maybe I can try to give this by 4 should be a center of the rotation. I can try to define any of the point. So from that part, it is going to keep the rotation. So from that part, it is going to rotate the entire images. So it is going to flip the entire images. And this is what happens even in your mobile devices. So you try to set all of these parameter just by using some sort of an icon. But yeah, programmatically, this is someone has, even the software which is running in your mobile, someone has written some sort of a code. And again, this sort of a code is running behind the scene. As simple as that. So hope this part is clear. Let me ping you this particular code as well. So you can try to maybe like play around with the center of rotation, degree of rotation, and the shape of the images that you would like to keep it for yourself. So here I'm going to like give 90 degree rotation, all those things. So I am able to like perform the rotation operation with respect to the images. Now let me show you a couple of more operation with respect to this images. So here let me show you. Okay, so some sort of a image shifting operation. So maybe shifting on right hand side and shifting on left hand side, and maybe down and maybe up. So here to shift these images, what we can do is, so we can try to call numpy dot float, float, float 32, and then we can try to say that, okay, so shift right by 50. So shift right by 50. So 1, 0, 50, and then shift down by 100. So 0, 1, reverse of it, 100. And yeah, so that is going to create my main point, for example, and numpy, it is not able to recognize. So import numpy as np I can do. Now, so cv2 dot wrap affine, and here, so I'm going to wrap my images with the above variable or above implementation with same width and height. Okay. Now this is going to give me translated image, let's suppose, and I just have to showcase those translated images to all of you. Yeah. So as you can see, it is basically shifting my images. You must be able to see a black over here, right? So it is shifting 50 scale or 50 pixels right hand side, and then from above you must be able to see. So it is trying to shift my images by 100 pixels down. I can try to change these values, and then you will be able to see more visible result. So maybe 500, and then here, so I can try to do maybe 1,000, and now it's like it has shifted completely down, as you can see, right? So I don't know whether it's visible or not, but yeah, so it has shifted my entire images completely down. Maybe I can try to like keep it 200 just for the visibility purpose. Okay, height I have given a lot, so let me change this height. So 500. Yeah, so it is shifting like a right hand side, it is shifting down. So right hand side and down, all these things I will be able to control based on the value which I am going to give over here. And yeah, so I will be able to shift the images above and below and down. Okay, now, so there are other things as well that you will be able to do. So there is something called as blur. I believe even in mobile devices, so we sometimes use a blur. So there is a blur function which is available directly. I can call my images over here, and then I can try to say that, okay, so when you are trying to blur those images, so what kind of a matrices you are supposed to resize or like take the average of it. So let me explain you the meaning of this one. This is going to produce a blur images by taking 5 cross 5. So blur, and here, so I am show, and show me basically a blur image. Blur image. So here you must be able to see some sort of a blurriness, but maybe not much. Now I'm going to change this one. I'm going to make it like a 50 cross 50. 50 cross 50. Now you must be able to see a lot of blurriness, right? A lot of blurriness. Now technically what it is trying to do, so when I'm writing this 50 cross 50, right? When I'm writing 50 cross 50, so it is trying to take a array of size 50 cross 50. It is trying to replace that with the average of that particular data, right? Average of that particular data. So this is something called as mean blur operation. Yeah, mean blur means it is trying to take the average and then it is trying to blur it. Means whatever number that we have, just it is trying to convert it into the average of it, so that the exact value of the pixels will not be visible to all of you. This is the meaning of a blurring, by the way, right? This is the meaning of the blurring. So if you are going to like increase the average, your image will be more and more blur. If I'm going to decrease this one, so my images will be less and less blur. As simple as that, right? So less number of pixels, it is trying to like do a mean of it, average of it, basically. So this is one of the blur operation that you will be able to find out. And this is called as mean blur, by the way. Yeah. So mean of this data, it is going to replace it. That's it. This is something called as blurring. Now there is something called as Gaussian blurring as well. So here, Gaussian blurring. So CV2 dot Gaussian Gaussian blur. Yeah. So Gaussian blur, it is again going to do the same thing. So I can take the images over there, and then it is going to take the pixels of some size, and then it is going to take this input parameter, and again it is going to perform some sort of blurring operation. Let me increase a size so that things will be visible. What happened? K size height. Okay, Gaussian takes the same size. Gaussian, fine. It should work. 20 cross 20 I have taken. There is no error. So OpenCV, this, Gaussian blur, maybe it is not able to identify, create Gaussian kernels. K size height, percentile 2 is equals to 1, K size height should be greater than 0. What's an issue? 5 cross 5. So you must be able to see like a little bit of blurry operation it is able to perform. So this is again another one by which you can do a blurring. There is something called as median blurring. So like lot of functions which has been given. So median blur is again another function which you will be able to find out. So image and then try to pass median that it should take. So here median blur. Yeah, not much visible. Say median blur dispatch error assertion fail case size dimension should be lesser than equal to 2 and case size percentile should be equal to 1. Okay, looking for the odd number. Got it. Same issue was there even with the before. So this is something called as median blur. It is trying to perform. So 51, let me give 31. So yeah, it's trying to like show me a blur operation, and all of these things we must have seen even in our mobile devices or whatever editing software that we are going to use it. So it's actually coming from these piece of the code, by the way. Okay, so is it making sense to all of us, guys? Yeah. So this is for a blurring. Fine, everyone. Anyone who is having any kind of a question, so please go ahead. I'll try to answer your question. But yeah, these are like just a simple function which I'm trying to use, which is an inbuilt one. I'm trying to show you all sort of operations with respect to the images. This is what I'm trying to do over here. Okay. Now let me show you some sort of a edge detection. So even in this particular things must be available in your mobile, and you must have used it at some point of a time by applying or by calling a filters, right? And this is what I'm going to show you even now. So here I'll try to show you some sort of a edge detection. Edge means those lines inside the images, the different kind of a style of the lines. So where with the help of line sketch, you can try to identify the images. Now here, to show you the line, I have to convert my images into a grayscale, which I have already used it earlier. So GRAY, gray, I believe, yeah. So grayscale image is already available. Now what I can do is, so CV2 dot Sobel, SOBEL, Sobel. And then here, so I can try to pass my grayscale images, then CV2 dot CV64F. And then let me show you. Sobel. Let me call this IM show. Kernel size greater than the order in a function. Okay. And assertion failed. K size. Get Sobel kernel. Okay, so I have created basically a Sobel for X. Let me save it in this way. Now copy the same. And Sobel for Y. So gray CV2. So 0, 1, 0 and 0, 1. X and Y. So final Sobel is basically CV2 dot magnitude and then Sobel X comma Sobel Y and then show Sobel. Yeah. So now, as you can see that it is trying to show me like some sort of a line inside this particular images, and it's very hard to identify this entire images when I'm trying to show you like as a Sobel. Now basically, let me show you in a little bit better way. So here Sobel, when I'm trying to call. So Sobel dot as type, and let me change this type u int 8. Yeah. So now you must be able to see a line or a sketch kind of a images of mine, right? A sketch kind of a image. It's a beautiful image that I believe we are able to create. And again, similar kind of images, usually we try to create it even in our mobile devices, right? We can try to like edit it. So same thing I'm able to perform even over here with the help of something called as Sobel, basically. So I'm just trying to do some sort of a manipulation with respect to x-axis and y-axis and trying to change the color gradient over here. And eventually with the help of Sobel function, I'm able to perform this operation. This looks beautiful, by the way. Yeah, so maybe I can try to like save it somewhere. Yeah. Okay, so Sobel is one of the edge detection. There is a famous one called as Canny, C-A-N-N-Y, Canny edge detection. So Canny, and here also we can try to pass a gray, and then we can try to pass a shape of this. And the output, I am going to store it as a Canny, and then I am show what? Canny, C-A-N-Y variable name. Okay. So this is called as Canny edge detection. So again, we had a Sobel and we had a Canny. So again, we are just able to see the lines over here, and with the help of this Canny function, we are able to do it. So this is again one kind of edge detection that you can try to do it. So Canny is one, and then Sobel is another one. Okay. So these are the different kind of things, guys, with respect to the images. And likewise, you can like do another like any kind of a image transformation, right? Any kind of a image transformation, whatever you can do it in your mobile devices. Each and everything can be done with the help of this CV library, OpenCV library. This is how powerful this entire library is. Not just that. So beyond this, a lot of like object detection, a lot of object segmentation, you all will be able to do it. But yeah, so I believe now we understand that what is the power of this like a OpenCV library, and whatever transformation that you are looking for with respect to your images. Like I said, there are more than 10,000 plus function which people have created. Again, if I'll talk about the parameter, so a lot of parameter, it's a 20-year-old library, right? Since last 20 year, people are doing a development, and that too, like it's an active development that people are doing with respect to this library. So just imagine how many function we have, right? How many function we have, and like what and all things that we can do it. So almost everything, not almost, I would say like everything you all will be able to do it. So whatever kind of a transformation that you are expecting, I'll simply suggest you that go to Yuri, ask that, okay, fine. So can you please give me this transformation with respect to OpenCV Python? It is going to give you, and you can just apply those transformation anywhere you want, anywhere of your choice. Making sense? Shall we move ahead, guys? Now, yeah, everyone. Yeah. So waiting for your yes or no, guys. Okay. So once we are able to do this, right? So now what we can do is we can move towards object detection, basically, and where we can try to access our camera, the live feed. I'll try to teach you that how you will be able to access your camera. And as of now, obviously a BIF camera, but yeah, so in the similar manner, you will be able to access any IP camera. So any camera will be attached to some of the ports or some of the addresses, right? And it's a physical device, so that you will be able to access it. And then whatever kind of a application that you would like to build, you can try to build all sort of a application in no time. So that is basically possible. Now this is something which I'm going to show you. And during this process, so I'm going to introduce couple of like a object detection module. So there is something called as YOLO, you only look once. There is something called as SSD, single source object detection, and there is something called as RCNN. There is something called as faster RCNN, and there is something called as like a masked RCNN, basically. So these are the library, or these are the models architecture which is going to help me out in terms of doing a object detection. Now, those who are not aware about like what is where do we use a edge detection? I'll show you. So edge detection. So I'm going to show you now itself. Yeah. So again, whatever kind of a image manipulation that you have to do, right? So everywhere we are using those edge detection. Plus, I'm going to use it even in my lane detection. So here, let me talk about object detection a little bit. So I will try to go to ultra analytics, and this company is actively doing a lot of improvement with respect to a model series called as YOLO. And YOLO, you only look once. It's basically one of the architecture, one of the object detection and like a convolution neural network architecture. So which is going to help me out in terms of doing a detection of a particular object. So for example, if I'm going to take an image, or even now you all are able to see me. So if system can identify me as a person, if like a system can identify maybe a mouse, maybe a pen, maybe a mobile devices. So that is something called as object detection. Now, we have already seen a classification. Classification means nothing but learning from a kernels and then trying to say that, okay, fine. So this image belongs to this class and this image belongs to that class. This is the meaning of a classification. But when we talk about object detection, so it simply means that try to create a boundary box around the objects. Let me show you a couple of images. So here, object detection. Yeah. So this dog, as you are able to see, or maybe this like a mouse you are able to see. So basically drawing a boundary box around that particular object, and inside one single images, there can be a multiple objects that you will be able to find out. So identifying all of those multiple object inside images and then giving me a boundary boxes with certain confidence score, and that is something called as object detection. Now, where object detection can be used? Everywhere, right? Everywhere. So whether it's a intrusion detection, whether it's a traffic signal, whether it's a like a autonomous car, so or whether it's a facial detection system. So everywhere you will be able to find out and use case of a object detection. And now to do that, there are multiple algorithm which is going to support you. So we have seen classification. Now I'm going to show you basically a detection and a segmentation. Both I'm going to show you with respect to some of these models, which is a pre-built model. And again, so in our upcoming classes, so 1 or 2 model, we are going to train it from the scratch, because to train those models, so we have to label the data. We have to draw the boundary boxes with the help of maybe a label IMG, or nowadays even some of the automated tool which is available. Some of them are like best one is paid one, but yeah. So we have to label the data. We have to label a lot of data. We have to create a huge amount of a data set with the labeling, and then only we'll be able to train it. And I think we have been doing it since last personally, if you ask me, so I have been doing it since like a last 7 year, I would say 7 or 6 year. And when 6 year back or 5 year back, when we had to create a lot of this detection image object detection models. So we used to do it from a very scratch, but now we are in 2025. We are in a era of AI. So now a lot of models are already available with the best of best, which has been trained with a different kind of a data already, a massive huge amount of a data already. But yeah, back then, like a 5 year, just 5 year, 4 or 5 year back, so we used to do a lot of training and a lot of like a data labeling. And again, so we used to hire hundreds of interns. They just do only one thing day and night. So drag with the help of mouse, and then they used to label it. They used to create the images, and then we tried to do a setup, and we used to train the model. We test it again. We used to retrain it. So that was the process that we were following before. But now we have some of the best model available to all of us. So here, to show you the demo of this YOLO, so Ultra Analytics has already released its library. It's a PyPy library. They have already released it. It's a Pythonic library, and I will be using that. And based on that, I'm going to show you all this kind of a demo. Plus, they have some pricing as well. And yeah, so they are giving you a lot of things inside this entire ecosystem, so that you don't have to go and do anything on your own, basically. And even you will be able to train based on your data set, but you don't have to go through this pricing part at all. I will be showing you without even like logging into this Ultra Analytics, just by using a Ultra Analytics PyPy packages. So let's try to understand, guys, that how we will be able to do object detection, how we can try to perform all sort of operations. So here, let me go to my this one and close this, and let me create a folder called as object underscore detection. Okay. Now, so to detect any kind of a object, I can try to pass images. I can try to pass a live feed, a camera feed, live camera feed. I can try to pass basically maybe pre-recorded videos, because at the end of the day, system is going to treat all of these things as a set of images. Even if I'm going to pass a single image, system will consider that as a single frame that we have already seen inside our CV2 libraries. If I'm going to pass a videos, it's nothing but it's a sequence of the frame. Or if I'm going to give an input through my live camera, through my live web camera, so again it's a sequence. It's a sequence of the input or sequence of the frame it is going to consider. Means ultimately for a system, it's a single image at a time, right? Even though if I'm going to give a live feed, it's a single image at a time. So one by one, it is going to process it, and then eventually it is going to show me the final result. So any question for me, guys? Anyone? Okay, so let's do it. Let's write some sort of a code which is going to help me out in terms of doing this sort of a detection. So here, what I will do is, so I have our detection folder. Maybe I can try to create a new file, and I can name it as a live cam feed dot IP. Sorry, not IP. Just keep it as a Python file for now. Live cam feed. And let's try to import a library. So import CV2, same library that I have used, because at the end of the day, I have to deal with the like a frames. Basically, it's an image that I have to deal with. And then try to import Ultra Analytics, the library which I have shown you, or the company which I have shown you, right? So before that, you have to do a pip install. So here in your current environment, just do one thing. So pip install install Ultra Analytics. Otherwise, it is not going to work for you. And their pip is already available. Just for the model. So we are going to do it. we have to access their trained model. Can we use one environment for all the project? Yeah, same environment I'm using. I have not changed the environment. So just use the same environment and you can do the installation, at least for today's thing. So just do the installation, guys, and let me know once it's done. Okay, so this installation seems to be done. Okay, so here, once this installation is done, what I can do is I can try to call from ultra TRA, ultra I can just copy it. It's not able to detect. Ultra analytics. Yeah. So import YOLO. YOLO is the model. So they are going to like give it to you. So I'm going to like use this model. You only look once. That's a full form of this YOLO model. It's been trained based out of the convolution, convolution model called as a darknet. I'll talk more about it. Just wait for this particular demo. So def main I can try to write, and then inside this I'm going to write like a CV2 dot video capture, VIDEOCAPTURE. Yeah, video capture. Now video capture, now what this video capture is going to perform? So this video capture is going to invoke my camera, my bev cam or any other camera which is which is available to my system. So it is going to invoke all of this camera. In general, it will be available at 0th indexes for most of you, by the way, right? For me, it's available at index number 1, but yeah, you should use 0. First try with 0 and then try with like a 1, 2 and so on. Why I'm using 1 in my system? Because I have attached a multiple camera. As you can see, one camera with which I'm live in your class, and then other camera I will be using just to show you this particular demo. So I have 2 cameras attached to my system. Because of that, I'm using 1th indexes. Means at 1th indexes my other camera is available. The camera which is available at my 0th indexes, I'm already using it basically. But yeah, for you it should not be 1, it should be 0. If you're going to give 1, maybe it will not be able to invoke it. So now this is going to access my camera, CV2 video capture, and then this one. So once I'm going to access my camera, right? So here what I can do is I can try to maybe load a model. So model is equals to YOLO, YOLO, and then here, so you can try to load a model for a very first time, YOLO V8 version 8 nano.pt. So this is the YOLO version that you can try to load it for now. Now let me align it. Yeah. So this is the model. So it is very simple. Someone has already trained it. I'm trying to open up my camera. I'm trying to open up my I'm trying to access the model. I'm trying to access from the Ultra Analytics, and camera I'm trying to access from this CV2 library. This is helping me out in terms of accessing the camera. And then I can try to run it in a loop. So while true, which will be true all the time. So it's an infinite loop. So camera capture the dot read. So read the frame. So start reading the frame. This cap is nothing but, so start reading the frame, and then it is going to return you 2 things. So it is going to return you ret, and it is going to return you the frame on which you are going to perform a different kind of a operation, right? So here what I can do is, so I can try to call model dot prediction, DICT, predict. And here there is a parameter called as source. So do a prediction on what? So the frame that you are capturing from the camera. So try to do a prediction from that particular frame. Show false for now, and confidence score is equals to I can give 0.5, half confidence score. So now this is going to give you a result, means a final prediction it is going to give you. So I'm going to store it inside the result, and then I have to show you that result. So basically I can try to like plot that part. So result of 0, whatever result which I'm getting, just try to plot that result. Show me that particular result. So this is called as detected frame, DTCTD detected frame. So frame by frame I'm going to show you. And then cv2.im show, same function that we have been using. I can say that live object detection from my webcam feed, and then detected frame. Just show me the detected frame. So this is going to show you the final detected frame. And then I can try to write some sort of things for a termination. So if cv2 dot wait key, so if I'm going to wait key 1 and OXFF hex code is equal to order. So if you're going to press Q, by the way, so it is going to break the loop, because I'm running while true. While true means I'm into an infinite loop. So if you're going to press Q or wait key 1, so in that case, it is going to break this particular loop. This is what I have written. So means keep on taking the frame, keep on, as you can see, keep on reading the frame, keep on doing the prediction, and keep on showing me the result. All three things I'm trying to run in what? All three things I'm trying to run into a infinite while loop. So I'm just trying to break it. So whenever you are going to press Q or maybe wait key 1, it is going to like do it. And eventually it, once the loop will be break, so cap will be released, means the camera access which it is trying to do, it will be released, and CV2 destroy all window, destroy all the windows. So whatever windows it has opened up, it is going to destroy it. This is what I have been doing even over here, right? All the time. So whenever I was trying to show you, so destroy all the window and then like wait key, and here I'm trying to use just a release over here. So nothing different which I'm trying to use. And then let's call this main function. So if underscore name underscore is equal to magic function main underscore call the main function. Yeah. So this is the code, guys, by the way. I don't think that it's tough to understand. Now let me test this code and let me check whether it's working or not. So here I can write Python live. Okay, so inside my object detection folder, I have this code. So object detection, cd object detection, and then Python live cam feed.py. Just change your camera port number, guys. I am using like a 1. You should use 0. Try with 0. Why we are writing 1? Why can't we write 0? So you should write 0 basically. I am writing 1 because I am using multiple cameras. So on my index 0, camera is already busy. Basically, with that camera, I am live in your class. The live feed that you are able to see, my face that you are able to see. And there is another camera, so which I am going to use it for the experimentation. That camera is available at index number 1. Yeah, so downloading the model. So yeah, it is able to download the model. And here I am with my another camera. Yeah, I believe I'm able to, you all are able to see me, guys. Yeah, with my other camera. So this is what I was trying to show you. So, but yeah, so you have to basically like use 0. Try with 0. It should work with the 0, by the way. Fine, everyone. So as you can see, so it will keep on taking the frames, keep on reading the frames from one of my camera. Then it is like trying to pass it frame by frame, trying to do a prediction, and then it is going to show me. It's in an infinite loop. Unless and until I'm not going to press Q or wait key 1, it will keep on running. And you must be able to see everything in a print, right? That one by one it is trying to like take these images. Now maybe I can show something to this one. Maybe like let's see whether it is able to identify mobile or not. Cell phone, yeah. So it is able to identify cell phone over here. So yeah, perfectly fine. Then it is able to, okay, even this is treating as a cell phone. That's fine. This one as a cup, yeah. So perfectly fine. As a cup, it is able to detect. Now what? Like a pen maybe. Okay, so not able to identify because of my person boundary box. Yeah, big object it is able to identify. Yeah, book. So book it is able to identify. So this is like everything is happening. All this object detection is happening in a real time. In a real time, I'm able to take a feed and then like I'm able to process it. Right? I can try to even store each and everything into the database. So if I would like to store frame by frame, image by images, I can try to store that. Whatever I want, I can do it because now everything is accessible to me and to my system. So are you able to execute it, guys? This one? Yeah, anyone who is able to execute it? Please try to use a like a index 0 for a camera. Durgesh is saying yes, working fine in my system. Great, amazing. Devi is saying yes, I have executed. Great. Hmm. Anyone else? No? Only two people? Santosh is saying working, sir. Okay, that's great. So fine, I'm going to terminate my infinite loop while true by pressing Q. And yeah, it's been terminated. And as you can see, so it is going to give you everything. Like it is giving you result one person, one couch, right? One person, one couch on this particular frame. Now you can try to store all of this information, even frame by frame data, you can try to store it. At the end of the day, you can see that it's a image processing. So this is what I have shown you CV first of all, a CV library, right? Which I have shown you. So basically those like a CV library, right? Where I was trying to do an image transformation and I was able to process a frame by frame images. Technically, it's the same thing, right? Image by image, frame by frame. It's just like I'm running something in an infinite loop while true. And that's the reason you feel like I'm getting a streaming of the data. Obviously, I'm getting a streaming of the data, right? But the like the data which I'm trying to pass inside my YOLO model and the data which I'm trying to process, technically it's a image, as you can see over here, shape. Every time I'm trying to take the images, and then on every images it is able to detect something. So one person, one couch, one person, one couch, something like that. Now, so moving ahead, so one demo we are able to do it, right? So where we are able to access YOLO and we are with the live feed basically, right? With the live feed. So and that too with respect to the images we are able to work. So now what we can do is, now I have a couple of video basically. Let me show you those videos by the way. Mm. Yeah. So I have a couple of videos over here, which is like which I have taken from open source, and it's basically a video, a lot of video I have, not just one or two. So basically, it's like a video of a road where vehicles are running, right? So vehicles are running on a particular road. Now, if I have to build a system, so which should be able to detect the lane that we are able to see, right? The lane, and if it is able to detect other objects which is available on the road. So maybe I can try to write some logic on top of it, right? So as you can see, as of now, I'm able to detect a couch, I'm able to detect a person, all of these things I'm able to detect, I'm able to get it as a output. Now, if I have to write some sort of a logic that whenever you detect a person, right, whenever you detect a person, now store only that frame into the database, or maybe try to call some sort of a action. For example, let's suppose I'm dealing with a security camera. You just have to do only one thing. You have to like put an IP address over here. There is a library even for reading out the IP camera. And generally when we work on a real-time project, right, so we always try to like fetch all those information from an IP camera. It's not that difficult. Same CV to library, you can try to use it, and you have to pass the IP addresses. That IP address must be whitelisted, or if it is a password protected, then you have to pass the password. That's it. So you can access any of the camera in this entire world. Even if you have like a IP camera in your house, you can do it. Now, so I'm able to detect the object inside the images, and I'm able to print it. Now, if I have to write a condition that if a person is been detected, then do this, right? Maybe raise an alarm, or maybe send a mail, maybe like log that data into a database. All these things can be done. Yeah. All these things can be done in a easiest possible way. You just have to write the condition, and then like, are you able to get my point, guys? Are you able to understand the use cases, by the way? The use cases which I'm talking about? Yeah. So you can try to write those condition, and this is what we do. This is how, like, we try to build this entire things, right? Build this entire things at the end of the day. So here I'll just show you one condition, right? So let's suppose we are able to detect a frame, right? We are able to detect the frame. I'm showing you this particular frame. Now here I can maybe like try to write some sort of a condition based on this particular detection, by the way. So let me do that. So here result 0. Now this is giving you a class, by the way. So like whatever things that it is able to detect, so result 0 is giving you this one. I'm going to store it as a results, for example. So results I'm going to showcase, and maybe on top of this I can write the conditions that results dot boxes boxes, yeah, boxes dot class dot cpu dot numpy dot as type integer. Now this is going to give me classes. So I can write a condition that if 0 in classes, then do one thing, just try to print person detected. Okay. So here I'm just trying to like fetch the classes, and then based on that I'm trying to perform a print operation. Now at the same point of a time, if I want, I can try to store this frame somewhere. I'll show you that as well. So here let me run this part. live cam feed. It will take couple of minutes initially to start the frame. Okay. One person, send them this one, trackball, attribute, built-in functional method, object has no attribute, as type. Okay, fine. Results, boxes, class, CPU, numpy, CPU, numpy as type. So results is equals to this of result, then boxcs class CPU looks good. Okay, numpy as a function, then as type. Small mistake. Yeah, so now I have started getting this one, and if I'm going to terminate it now, so Q, you must be able to see that it is printing person detected. Person detected, it is printing person detected. Yeah. So this is what I have written, print person detected. Now let's suppose I'm moving one step ahead, and whenever it is going to detect a person, what I want is, so it should write basically like that particular image. It is supposed to basically like write it down, or maybe whenever person will be detected, so it should play some sound inside my system. Anything can be done, right? Anything can be done. By the way, so here I can try to like maybe right here I'm doing a image so detected frame. Here I'm taking a frame. So whenever if 0 in class, write a condition that cv2 dot I am right. I am right. So this is basically going to write a particular images. So here person dot jpg, and write what? So write basically my frame. So the frame which I am capturing. So if inside this frame there is a person, write it down. Now I'll try to even show you that I can save this entire like whenever there will be a person. When there is no person, it will not save it. When there is a person, it is going to save it. So I can call any kind of action, by the way. If I have to trigger alarm, I'll show you even alarm in my system. If I have to maybe store something into a database, if I have to maybe like do some sort of a automation if person is detected, maybe send some sort of a SMS. If you remember, or I don't know whether you have gone through that or not. So I have even recorded one video, so where I am connecting with my WhatsApp. So if you, I've shown you that in a live, basically. So you can try to integrate even that kind of a system. So whenever there will be a person, send a WhatsApp to someone. So yeah, here person is detected. Now Q quit, and then here I'm able to see a person.jpg. See, in this frame, person was detected, right? And it is able to save it. It is able to save this particular person. So inside this condition, I have just written. Now similarly, I can try to like write something like a play a sound inside my window. So to do that, maybe I can try to import a library, import win sound. So there is a library called as win sound, and here, so whenever there will be a person, so win sound dot beep, beep, beep. some numbers I'm going to give. Yeah. So now it will keep on beeping. I'm just writing everything inside the condition, same condition that, okay, if there is a person, there is that class, 0 in class, then just do that. Yeah. So are you able to hear it, guys? A beep. Yeah. So I can play an alarm over here. I can configure anything, right? So as per my need. Now, in case of autonomous vehicle, let's suppose there is a person or there is cat or there is some living object which has been detected. So you have to just give a command to your brake that, okay, automatically apply a brake or maybe try to turn your steering, right? So again, based on these situations, so we write a lot and lot of conditions. So once we are able to detect it, once we are able to get a different classes, basically based on that, we can write any kind of a condition that I want. So if there is a bumper ahead, so maybe just try to slow down, maintain this particular speed of a vehicle, or maybe take a left turn, take a right turn. We are ultimately, we are like giving this command or control to our like a programmable device. That's it, right? And ultimately that is going to move my mechanical device at the end of the day. My steering or my wheel, it is going to move at the end of the day in case of a. So opportunities wise, a lot of opportunities you will be able to see. Whatever you can see around you, you will be able to automate it. You will be able to like just by writing a code. So this is where a beauty of computer vision comes into a picture. It's a very powerful area, very powerful field. And yeah, so I believe you all are going to love it. So image writing sound, I'm able to play. Now similarly, if I have to store something into my databases, so I'll try to call my DB object, DB connector, and then I will be able to save it inside my database. That's it. So let me ping you this first piece of code, guys, to all of you. So now even you can play your sound and all those things, you can do it. So in this place, you can do anything that you want. Now, so let's try to write a code. So where we will be able to detect a lane basically, and then eventually we are able to detect a vehicle, right? So we will be able to detect a lane, and yeah, so based on the lane, and I'm going to take a input as a video feed. I'm going to take an input as a video feed inside that one, and it is going to help me out in terms of detecting a lane and in terms of basically like processing this entire things. So here I will try to create one new folder, and I'll say autonomous vehicle. I will be using same environment. So environment I'm not changing. Autonomous vehicle. Now here I'm going to create one file called as lane detection dot py file, and another file I'm going to create just to keep things modular a little bit. Otherwise you can keep it in same one. Lane detection, and one is basically uh, video processing .py file. So these are the two Python file which I am going to create, guys, over here. One is for lane detection and one is for Python. Lane detection code is a complete like a CV2 based code, and whatever I have discussed, whether it's a canny, it's a Gaussian blur, CVT, everything is been used. Everything means literally everything. I'll come to this particular part of code. Yeah. So whatever I have discussed today, I'm using it in my lane detection. So it's a pure CV2 code that I'm using. It's not a pre-trained model I'm using for a lane detection. I'll try to go through this code. I'll try to explain you that part as well. Now, so there is a code, same code I'm going to use for a video processing lane detection. So lane detection, import this one. Okay. Now what I'm going to do is, as I'm sitting in a room, so obviously I can't just go out and pass a live feed to the camera. I will be using a video, by the way. Yeah, I'll be using a video over here. So one of my video which I have already shown it to you. So I will be using those videos, and let's see so how it is going to perform. So here I'm going to keep one of the video inside this folder, and let me change this path. This was the path when I was building it before. Model, let's remove this part as well. Yeah. So now code wise, you will not be able to find out anything different, by the way. The code which I have shown you just now, just by writing it, it's the exact same code we are using. So instead of video capture, by taking a feed from the live camera, I'm trying to pass one MP4 video. That's it. And the same function, right? Same function, video capture. So this is the video which I'm going to pass, as you can see. So this is the video. I have such like a lot of like a videos. So where it should be able to detect a lane, and where it should be able to detect basically a vehicle which is available on a road. Model wise, exact same model I'm using. Again, it is trying to read frame by frame, right? And then it is calling a detect lane. I'll come to detect lane function. Detect lane is a complete CV2 based like a function that I have written. As you can see, today itself we have discussed Gaussian blur, canny edge detection, right? I'm using it. Someone has asked me a question that where we can try to use this edge detection. Here we are using edge detection. How? Let me run this entire code, and then I'm going to share this code with all of you, and then I'm going to show you that part. So Control S, and then, so it's not different. So same code which I have written just now, I'm using that one. CD dot and then CD autonomous vehicle. dir. Okay, so I have all of these. So Python video processing. Cannot open video. Okay, it's a ND1, ND7. Yeah. So as you can see, it is able to detect a lane, this green one, and then in between. So you must be able to see some sort of a boundary boxes. So this boundary box is nothing but it is detecting a basically like it is trying to detect a vehicle which is available on a road. So by processing a video, maybe I can try to change a confidence score to 7 for this one. Control S, and then yeah, so even middle lane it is able to detect, and then reason boundaries across. Even it is a curve lane, but still it is able to like detect it. Even middle part of the lane from a video, it is able to detect it. Maybe I can try this out with some other videos as well, some other feed. So I can try to change it to maybe a 9 number video. Yeah, so lane detection looks good. Car it is able to detect, as you can see. Car it is able to detect again. Bus, okay, car. It is able to detect, plus lane it is detecting in a parallel. Traffic lights it is able to detect. So yeah, traffic light, car, one traffic light, one car, one traffic light. So all of these things it is able to detect. And again, if there is some living things which will come in between, so it will be able to detect that as well, right? So now those traffic like a signal and then car that it is able to detect, all of these things are coming from where? From this particular YOLO model, right? And it's not different. Just now I have already shown you, right? So live cam feed, and it's the same model, right? YOLO V8 NPT. So it's the same model that I have been using, and I was able to like run it through my live camera feed, and same model YOLO V8N. Yeah, V8N. Like both the version is same. 8NPT I'm using over here, which is able to take a frame by frame data from this video that I'm trying to pass, and it is able to read those frames, and then it is trying to pass those frame into a function called as lane detection, and it is trying to pass a same lane detection frame. So whatever output that we are able to get from here, whatever output that we are getting from here, so we are trying to pass that into a model.predict. Exact same thing, model.predict. Last time we have used it, right? Last time also we have used it. Exactly same thing we are trying to do over here. And then whatever frame it is trying to give me, we are just trying to show you the result. Nothing much we are trying to do. Now, so here, let's talk about this detect lane. Now, this detect lane is a pure computer vision library, CV based like a library function that has been written. So it is going to take a frame, it is going to convert those frame into a grayscale, then it is going to blur it, then it is trying to call a canny edge basically, so that whatever lines which is available, because if you remember, right, if you remember when I have shown you this canny edge, so when I have shown you this canny edge, this one, right, if I'm going to execute it once again, CV2 is not defined, let me call this first, yeah. When I have called this canny gray, fine, I have to execute even a gray variable. Gray is we have here. Okay, let me close, close, and close. Okay, let me like take this one directly, gray, CV2 canny gray, and I have to read the image. Import CV2. IMG is not defined. Where is my IMG? Oh. Yeah. So basically this was my canny edge. This is something which I have shown it to you, right? So now what it does is it try to convert your images into a gray. It always take input as a grayscale image, right? And then it is going to detect all of those edges, and we are trying to say that, okay, fine. So this edge, I'm just trying to plot it with the help of green line, right? So we are plotting it with the help of green line. We are saying that, okay, fine. So this edge that we are able to find out, this like a liney edge. So that is something called as basically edge detection. Now lane detection, yeah. So here we are trying to like take these edges, and this edge we are trying to pass in this particular function, region of interest. So this particular data that we are able to get it from here, and again there are a lot of parameter that we can try to like change all of these parameter in terms of doing a blurring, in terms of finding out the canny edge, and we can try to even make it better and better and better. Now here region of interest. Now what this region of interest is going to do? So this is going to basically plot those like a mask. Mask means those green line that we are able to see. So it is basically going to plot that particular part. So maybe instead of like a 255, I can try to give 0 over here. Let me show you with some changes. Yeah, 0 means now it's not visible to you. Let me keep it as a keep it as 175, because ranges will be 0 to 255. Yeah, so some lines that you are able to see. So I'm just trying to control the color of those lines, nothing much, and a lot can be done over here. So you just have to change the numbers, and it will keep on changing things. You can try to like change width and height of all of these things, right? So you can try to even like control this one. So minimum line length and minimum line gap in between, and in this way your edge will be even better and better and better. Now here I can control, let me keep it as 255, and here, so let me do it 255 comma 255 comma 255. Line color I am trying to control with this one. So there was a green, and then I can change it. So I can just try to play with the RGB. I can try to play with even like a distance between these lines, just as a part of fine tuning process, because at the end of the day, I'm just trying to play ahead with the images. And this is drawing my line at the end of the day. Yeah, this is drawing my line. I'm trying to find out the coordinate out of this one. So this is lane detection, guys. And inside the lane detection, so we are trying to basically like detect even an object. And then now we can write a control over here if we want that. Okay, so inside this frame, if we have this much, or maybe from like a lane, we have to maintain this much of distance, if distance between this, because at the end of the day, the lane that we are able to detect, so we are able to get a coordinate for each and every point, right? We are able to get a coordinate of each and every point. So when we are trying to detect a vehicle, so we can try to say that, okay, fine, so always try to maintain this much of distance from this particular coordinate. Means technically what I'm trying to say that you can write now any kind of a control that you want, because now you have a coordinates, and you can try to make your things as smooth as possible. This is what I'm trying to make as a point over here. Now let me share this code. Instead of sharing this code, maybe I'll try to share this entire folder now. Autonomous vehicle detection. And if you have any question for me, so please try to put up your question, guys. D drive code. Yeah, so let me, it's a 110 MB of a file. So D drive FSDS CV for today. Mohit is asking, does giving more confidence score, it will detect better? It will not try to make a lot of hallucination. This is what a confidence score is. Simply means that if there is some object which is giving you a threshold value above this, then only give me those boundary boxes. Otherwise, don't give me the boundary boxes. Yeah. So if I'm going to make a low confidence score, so it is going to give you a lot of like a boxes. Maybe that is not of my use. So this is what I'm trying to control with the help of this confidence. Yeah, so hope all of you are able to download your file, guys. Please check once. So learner is saying that how can we extract a handwritten data from a document, and also image recognition. See, for this handwritten data, so you have to use any of these OCR library. So maybe OpenOCR, you can try to use there is OCR from Amazon side. There is something called as EasyOCR. There is something called as OCR from a Snow Lab, basically. So you can try to use any of these OCR libraries, and that OCR library is going to give you a capability to do a recognition of any of these handwritten digits. Now, if you have to do some sort of a recognition of the images in the same frame, then you have to pass those frames through this YOLO kind of a model. Simple. So like for that, I think we all are sorted. Shall I show you OCR as well, guys? Yeah. Okay, it's not going to be a big deal because it's a very small operation. So maybe I can try to show you now itself. And so let me write like a OCR dot py file. Yeah. And what I can do is I can try to write something somewhere. Maybe on this image itself I can try to write. So I am so epic pen. And there are so many OCR library. Amazon OCR is one of the best one that you will be able to find out. Its accuracy is very good. But yeah, you can try to use even a Pytesseract. That is also fine. EasyOCR is also fine. So I mean, like you will. It's just a matter of accuracy. All of these libraries, so maybe I can write over here SUDHANSHU. And then here I can write EURON. Let's see whether I'm able to detect it or not. So I can try to maybe save. Oh. Yeah, I'm just placing this image that I have created just now where I have written Nanshu Euron, and let's try to use this OCR. So as of now, I'm going to show you this one with a library called as Pytesseract. But this is not the only library. Like I said, there is something called as EasyOCR. There is a OCR library from a Snowflake, a Snow Lab. There is a OCR library even from Azure, and even GCP provide you OCR. There is a OCR library that you will be able to find out even on Amazon. Like I said, Amazon one is a best one, but yeah, they are going to charge you. So pip install. This is the offline library which I am going to use. Pytesseract. PYTE SSCR ACT. Pytesseract. So this you can download in your local. Using cache, installing collected, successfully install Pytesseract. Okay, so I'll be using this library. Let me like read a image. So import CV2 and import py TRE TE py TE SSER ACT Pytesseract. Okay. And here, so first of all, I'll try to read the images. So I am read, and my image name is screenshot, right? SCREEN. Or let me change my image name. So rename to notes. I have just renamed it to notes. So I am read what? So notes. TES.jpg. So this is going to basically read my images. So IMAGE read my image. Now once I'm able to read my image, maybe I can try to change it to a grayscale for a better thresholding. So CV2.CVT color, and then here I'm going to pass my image CV2. So this is just an image pre-processing, guys. We try to do. It's not like it's a mandatory one. I can try to send this image directly, but I'm going to show you like what is a difference it is going to make if I'm going to send a image directly, and if I'm sending a image like with a pre-processing. So BGR, BZR to gray, GRAY. Yeah. So this is going to convert my images. Like I said, I can send the image directly, so there is no issue with that. But there will be a differences. I'll show you with the original image. I'll show you with the converted image as well. So let's do some sort of a thresholding over here. THERE, thresholding. So take a gray image and then just make it a bit better. CV2.THRE thresh binary inverted. Okay, so thresh whatever it is, and then Pytesseract dot image to only this function. This is the main function basically, image to like a string, and then you can try to pass your images. It is going to give you basically a output. I'm going to store it as a text over here, and then maybe I can try to print the output is this particular text. So this particular text, this is the output, as simple as that. And yeah, so cv2.im show. So here OCR input input. So input is a image, so you can see that image. Then cv2.show im show. I'll show you even grayscale images, how it looks like. GRAY grayscale images, so that you will be able to recognize it. I will try to show you even a image after a thresholding. So original, grayscale and thresholding. So CV2 IM show, and then THRES thresholded image. So I'll show you that part as well. And then CV2 dot wait key 0, and then destroy all windows. CV2 dot destroy all windows. Okay. Okay, so I can try to run this piece of code, ocr.py. So cd dot dot dir ocr.py. Okay, so python ocr.py. What is the error? System cannot find the specified file. Trace ball ocr.py line run in Tesseract. This. There is an issue with the package image to string. Okay, let me check what is the actual issue. There is a version issue, by the way. Let me check its official repo. There is a there is a window installer which is available, so I can use that window installer directly. Downloads, save. Next install for anyone. Then this Resizing deployment file, fine. Install. HTTP download error, download status you, click OK to continue. Okay. Don't want to see those things. Now let me check whether it's been installed or not. So C drive and then program file and then Tesseract T no program file 86 T, yeah, Tesseract OCR is installed here, and Tesseract.exe I'm able to find out. Let me copy this path, copy as a path, fine, and here I can directly use it. Tesseract.csv, it's available at this location. So read binary Pytesseract dot Pytesseract dot cmd is equals to read. Let me check now. Still error. Engine with the you can directly convert to image to string. I think I have made myself clear. So you are using a thresholding so that it will be able to detect edges inside. It will be able to clear out the separation between your background and the foreground. Foreground is nothing but your like a data that you have. So for a better identification, that's the reason. So I have written 3 IMSO, right? So that I will be able to show you that part. String. Image itself, let me pass. Line model image to string, it's failing. Let me download a version, guys. There is a issue with the download. So let me download binaries for Windows. It's a version issue. Old download till 3 point. It's a very old one. Example image test 5. Release and change log, downloads. Treasure Act 3 till 3 it's available. 3 is very old. Okay, 5 is also available. 5.3 is the latest one. Okay, let me download the latest one then. Please check the first part coding of the line number. Please check the line number 8. It's not line number 8 issue basically. It's a old version issue. So I'm using this 3.5 which is a 2015 version basically. This is a very old one. It's a 9-year-old version. It's a 2022 which is a latest one as per their official repo maintenance. So I'm just going to use this and then I'm going to test it with that one. It will work, just a version issue, nothing much. Okay, program file Tesseract OCR install. So this one program file, then Tesseract OCR. So I'll be using this path. Okay, so hopefully this should work. Yeah. So as you can see, it's basically working, and I'm just trying to show you a three different kind of a image transformation that I have done, guys. So one is basically a grayscale. Now this is what is happening into a grayscale. So I had a colorful images. It is trying to convert to a gray, simple. And then when I'm doing a thresholding, so as you can see, it is trying to even clean my entire images from a background to a foreground, right? So it's not like just to do some sort of a detection, right? Just to do some sort of a detection. So I just have to provide the images. I can provide the original image. Now output is SUDHOMWHE. So this is the output which I am able to see if I'm providing like original images. Now if I'm going to provide my threshold image, let's see whether I'm able to improvise my output or not. So Python OCR, and the output is SUDHAMN and then QHE. Then at the place of Euron, so CUREM. So as you can see, it is able to detect something, right? It is able to detect something, but not much because of like this difficulty in terms of detection of this handwritten images. But yeah, so till certain extent it is able to like detect some of these things. More I will try to refine my images, more I will try to do a pre-processing of the images, more better in a better way I will be able to detect it. Like I said, Tesseract is not one of the best library. I can go ahead with the Amazon OCR or I can go ahead with the EasyOCR. So making sense, guys? Yeah. So let me ping you this piece of the code with Pytesseract. And now you can try to pass any of your images, grayscale images, original images, threshold images, and then you can try to test it. Now I'll try to show you same thing with EasyOCR. There is something called as EasyOCR. So pip install EA SYOCR. This is again another library, nothing much. So you can do access denied. Okay, consider user option. It required torch vision. No option. So you can try the same with the EasyOCR. So maybe EasyOCR is going to give you like a better result. Maybe you can try this out and then show it to me. It is giving me some sort of a issue with respect to installation itself. I'm giving user, but still asking for admin permission. Users, or just a user. Now it's working. So here I can try to call import SYOCR, EasyOCR, and anyhow I'm reading the images, so I can try to use the same image. I'm trying to even convert that to a grayscale, so I can use original images as well as grayscale both. It doesn't matter at all. EasyOCR dot reader, and then I can say that try to read English. So whatever is available as a English, read it, then reader, and then reader dot read text. I can try to provide original image or maybe grayscale images. So provide image itself. It is going to give me a result, and then I can try to showcase the result. Print result. So I can mention over here that result from EasyOCR. Okay, IM show, it is giving me an issue. Okay, result from EasyOCR, and this is the result that we are able to get it, guys. And now if you will try to check this result in little bit detail, right, you will be able to find out that this result is technically a better result as compared to the Pytesseract that we have been using. So as you can see, SUDHAN, it is able to detect it. So it is giving you a lot of things, by the way. It is trying to give you a boundary boxes, it is trying to give you a text, and it is trying to give you a confidence. So three things in total it is trying to give you. Maybe I can try to take out just a text out of it. So result, where is my result? And result which I'm trying to show you, let me show you just a text. Execute. Yeah, so result from EasyOCR is okay. This is just a numpy. I just had to filter out the result. It is showing me. And if I'm going to pass maybe my grayscale images. Yeah. So what I'm trying to show you over here is that detection is good. Detection is good as compared to a Pytesseract, but not that great, I would say. So yeah, it is somewhere it is able to identify E as a AND symbol, EURON as a M. It is able to identify, and here so SUDHAN. SHU, I think it is not able to identify from anywhere. Yeah. So overall, performance wise, this is the performance from a Pytesseract that we were able to get, and this is the performance from my EasyOCR that I'm able to get. Now, if you have to look for the better option, I'll simply suggest you and advise you to go ahead with the Amazon OCR. It's actually very good, and in a production grade code. So generally, I advise people to use this Amazon OCR as it's very much reliable, and it's very much like a efficient. So hope this part is clear. Let me share this code with all of you. You just have to install EasyOCR, guys, nothing much. And I believe, guys, rest of the code I have already shared with all of you, and hope we all are able to learn something from today's class. So if you have any question, please go ahead. I'll wait for a couple of more minutes so that I can take your questions. Yeah. So any question, guys, anyone? Yes, anyone, guys? Questions for me? Okay, so if there is no question, in that case, we'll try to wind up this class. And tomorrow we are going to discuss again different algorithm for object detection itself by taking a live camera feed or by processing some sort of a videos. And I believe today we are able to understand a lot of things. So how to take a live camera feed, how to do a little bit of image processing, conversion of one images to a different images. Yeah, so OCR, out of context topic, right? So OCR was not a part of discussion, but still, as people have said that, now we are able to do it, right? Now we are able to even know at least two library. One is a Pytesseract and one is a EasyOCR library. I believe rest you can try to do it. Like whatever, like a Snowlab library which is available, or Amazon OCR or Google OCR, whatever is available, you can try to go ahead and use it. So hope it was a good learning for all of you. And now we even know that if we are able to detect some object, how we can write different conditions. So maybe play some sound, raise some security alarms, maybe send some notification to someone. And that was the whole idea. That was the whole purpose behind this. Dev Kumar is asking, if possible, then please show OCR use case in Gen AI project in Gen AI batch. See, use cases wise, there are a lot of use cases. Possibility wise, I never say no. We'll see. Yeah. So possibility wise, there is a possibility, obviously. So fine, guys, with that, thank you so much. And those who are coming to my Gen AI batch, so today I'm going to talk about an agent. So agent with respect to Llama indexes, Lang chain, Lang graph, and a crew AI. So how we can try to build a single agent, multiple agent, a chain of the agent. All these things we are going to discuss in my today's agentic AI class. So all of you are welcome. So those who would like to join from this class to that class is going to start from 2:30. So right after like 45 minutes, that class is going to start, and a lot of amazing things I'm going to discuss even over there. And in your class, this particular class, so tomorrow I'm going to talk about other object detection, like a algorithm plus segmentation algorithm. So you will be able to understand that now what is the difference between segmentation and a detection. And I think till today we are able to understand that what is the difference between a classification and a detection. So that is something that we are going to follow up in tomorrow's class. So with that, guys, thank you so much. And most probably by next weekend, your class will be over, including a project. Plus, I'm going to show you a multi-stage deployment. Multi-stage deployment means a multi-cloud platform deployment, AWS cloud platform deployment, Azure cloud platform deployment. So these are the things which I'm going to show you. And most probably by next week, Saturday or Sunday, we are going to wrap up the class. If there will be some topic which will be pending, we can take some sort of extra classes. We can try to prepare a list at the end of the class that these topics are pending. But I believe topics are not pending. I was just going through your syllabus. So fundamental image processing, this part is done. This part is done. Haze detection is done. We are able to even use it. This part is done. YOLO is done. SSD and faster RCN, I'm going to do it. Vision transformer, even image segmentation, I'm going to show you tomorrow. So this will be done. And then there is something called as image evaluation technique. So precision recall, these are the things that we already know. I think ROC IUC I have never discussed. So maybe I'll try to give you a glimpse. Grid search is something, and hyperparameter I have already discussed during my machine learning class itself. Then model interpretability and serialization. So this part. So this part anyhow, we are discussing it throughout the lecture. So when we are trying to create the models, cloud deployment is something which I'll discuss, a multi-cloud deployment, so that how on a scale you guys can deploy it. This is a pure theoretical part where like we talks about the ethics behind a model creation or AI creation. I'll be talking about this as well, but this is just a set of rules that, okay, so in some region this is allowed, this is what law says, and I'll try to provide you a documentation for this one as well. And yeah, so autonomous driving object detection. So this is something that we are able to do. First project is also discussed. So 3 project is pending, and I'll try to show you these projects or 1 or 2 project with a multi-cloud deployment. I believe by next weekend, we will be able to do that, because tomorrow this will be done. Yeah, tomorrow this part will be done tomorrow. So if this part will be done tomorrow, then the major part which will be pending is a project and its deployment. So I believe next week, hopefully we'll try to complete it. If not, then obviously we'll take another class, right? There is no hard rule that we have to finish the class next week itself. Agentic AI will be taught today. Yeah, in Agentic AI class. What about a project execution? I think first project execution we have done right after the machine learning, and that too with the ML ops concept. I believe that class went for 3 hour or 4 hour. If you'll go and check our machine learning project. So with a ML ops, Bappy has already talked about this project. This one I have discussed. The rest of the 3 project also I'll discuss. This is how we are moving, right? One section, one project, one section, one project. So yeah. Image classification we haven't discussed. So we have to discuss. This one also we haven't discussed. So we have to discuss. Time sentiment analysis for like a real-time sentiment analysis for social media. This is also not discussed. So we'll discuss. So we'll discuss the project and we'll do a deployment of the project. Yeah. So, and then we'll try to we'll review the syllabus if something is pending, because I don't want anyone to, come after a month of time and then complain that you left this topic or that topic, because that looks bad on me. From my side, after giving classes for a straight 6 months, if I'm missing 1 or 2 topic and people are coming and highlighting it, so I'll make sure that I'm going to cover those topics as well. Yeah, because what happens in general is like people don't remember you for your 6-month long classes that you are giving on every Saturday, Sunday. But they just remember you for like missing out maybe one single topic, and they will like keep on highlighting it that you are not completing it. You have written that in a syllabus. So we'll take a feedback from everyone. I'll try to like ping in a group, and after that, so if something comes up, we'll cover those topics. Because covering topics is not a big deal, at least at this stage, because we know a lot of things now. We have already discussed like a lot of things so far in 6 months. Okay, so with that, thank you so much, everyone. Take care and see you again tomorrow. I believe we all know what is the agenda for tomorrow. We'll try to complete that agenda in my tomorrow's class. Thank you so much.